Okay, so hello. So this is the project. This is the VPS setup in Terraform. VPC setup in Terraform. So this is the project I have deployed in Terraform in the AWS. So here is the project details. So explaining the project little bit. So there will be a VPC which will be created in using Terraform, and inside the VPC I am creating two subnets in the different AC. So one subnet is public subnet and one is private subnet. So in the public subnet there will be a Bastion host which I can access from internet. But the for other subnet, this is private, so we cannot access the subnet from the outside internet. So we have to access the subnet from the Bastion host. So we will access the Bastion host from this computer, and inside, so we can access the private subnet. So in the private subnet, there will be two EC2 or one EC2. So it will be in the auto scaling group. So I can increase the EC2 instance as the requirement grows. So it will be in the auto scaling group. So from the private instances, it will be a web server, so we can deploy web server in the instances, and from these instances we will serve the route using the load balancer. So this will be the load balancer inside the public subnet, and also in the we are giving the route table which will be the NAT gateway. So the private subnet can access the internet, but we cannot access the private subnet because it can support only one-sided internet. So we can access the internet from the private subnet, but outside the private subnet we cannot access that. So this is the NAT gateway which will give this feature, and we have to apply this all the thing using the Terraform Terraform code. So this is the Terraform code, and okay. So I am explaining the code. Actually, I have used the module inside. This is the custom module. This is written by me. I am also showing that. So this is the main file. Okay. So there is first module is main. The first module is VPC, which is creating actually the VPC in the this thing. So here is a variable, I think. Where is the variable? Okay, also this Terraform project using the remote backend concept. So this is the backend. So this is actually the backend is stored on the S3 instance, S3 bucket. I can show you the S3 bucket. So S3. So actually the state file is stored on the S3 bucket, which is Terraform VPC setup Terraform. So this is the bucket, and we cannot access this bucket because it is not public access. We can only access the bucket using the pre-signed URL. So I have shown you this thing, and also I am using a DynamoDB table for the state locking. So the DynamoDB table, DynamoDB. So this is the DynamoDB table. Okay, this is for state locking. So now there will be nothing, but it will use when we apply the changes. Okay, so this is the region, and there is main, which is the first module, which is VPC, and there will be uh, the module is here. Okay, this is the CIDR block for the module, and this is the VPC name. The first module is VPC. So this is the three thing. So this is the variable VPC name, VPC idea, availability zone. This is using two zone, subnet type. This is the CIDR block for the subnet, public subnet, and this is for private subnet. And the VPC is VPC info, the local using. So this is the local, and it is accessing the data from the variable.tf. This is the VPC Terraform code, and the CIDR is here, and this is the internet gateway. So we need an internet gateway to actually give the public subnet the internet access, because public subnet will access the internet using the internet gateway. After deploying this thing, I can show you in the AWS that how it is working. So I am giving this information using the code. So this is internet gateway. So this will be need for the public subnet, and this is AWS public subnet. Okay. So public subnet, there will be two public subnets. That's why I'm using count. So by using count, I can loop on this thing, and this will be have public IP, which is this will be the AWS Elastic IP. This will be Elastic IP, which will be used in the NAT gateway. So you can see the NAT gateway using this Elastic IP. Where is the Elastic IP? This is the Elastic IP. The NAT gateway actually using this Elastic IP. Also, there is a route table. So we actually need a route table for the subnet. So how the subnet actually route this thing, we actually can mention in the route table. So if a subnet is public subnet, we can give that there will be a route table for there will be a route condition which if if someone need to access something in the same CIDR block, same range, so he can actually go to local and check this thing. But if the range is other, so the range is different, then they can go to the internet gateway. That's why the public subnet gets the internet. So this is the route table. Okay, so route table have, okay, there is two route. One is for local. This is the same CIDR block. If I need to access something in the same CIDR block, it will go to local. But if I want to access other thing outside the CIDR, then it will go to the, actually this is for the private. So for the private, if we need to access the other internet thing, so we have to go to the NAT gateway. So for the private, we have to use the NAT gateway for internet. So this is the NAT gateway, and same thing for the public, we can access local and also internet gateway. So this internet gateway is using, and there is AWS private subnet. So this is the private subnet, and it will be false map, and we have to associate the public route table with the public subnet. So we can see, so it is associating this thing. um, this is for public and this is for private, and also we need to create network ACL NACL. So this is actually a security layer on the top of subnet, so we can block, allow anything here, but I am egress. The egress is actually outside traffic and ingress is inside traffic. So we are allowing all these things for the public and the private port. So we have to also attach this thing with the subnet. So the network part is complete. So we created VPC to subnet, and we given the permission that is needed. And this is the output for the module. We can access this thing. So actually it will output the result, which is the VPC ID, VPC this thing. So then the next thing is Bastion host, which will be actually placed on the public subnet. So this is the source, this is the AMI, and this is the name, this is the instance type, storage, ID. ID will be the returning ID from this module, and the subnet is also the same. This is the returning subnet from this module. So you can access the public EC2 Bastion host, this thing. So the same thing we can access the from this variable. Actually, we are passing this variable using the variable file from here. So if I go to the okay, first we need to create an AWS key pair. So I have placed a public key pair here. So this is actually the public key, and I have to also do one thing. I remember I need to change the public key. Mm, okay, so this is the public key. I have replaced it, and okay. So this is copying the file, and it will create the this thing in the AWS. So the security group. This is the security group, and Bastion security group. The security group will allow SSH traffic, and for the outside, it can access anything. And for the Bastion host, so it will be AMI is this thing, instance type, then key name. Key name will be this thing. This is the key. Subnet is provided. Security group is provided. Associate public. So this will be public. So this is true. And this is the root volume and the volume size. So all of this thing for the Bastion host. Then the next thing will be private EC2 template. So it is same the module and the security group. No, this will be Bastion security group. So I need the security group from here. So why I need the Bastion security group? I will talk later. The private EC2. This will be the size, the VPC ID, AMI, EC2 subnet, ALB security group, and okay, this thing will also come later. So private EC2. Let's see what is private EC2. So launch template, the same thing for the same. This is the key. This is the security group. Same thing, but here something is changed. Here it is accessing the SSH, but the inside the security group there is not mentioned any CIDR block. There is only mentioned a security group because this security group actually it is the main concept is if I mention ingress rule using the security group, so only the security group it is attached on any instances, then the instance can access this security group. So by using the Bastion security group, only the Bastion instance can access this instance. So this is the ingress. This is the port 80. Okay, so this is the web server. So that's why I am using port 80. So it will be also open. And okay, same thing. We have a application load balancer. It will we have now it is not created. So we will have a application load balancer. So there will be a security group also the for the application load balancer. So only the application load balancer can access the this ingress traffic. That's why I'm mentioning this security group. And for the ingress, it can access anything. The launch AWS launch template. So why are we not using the EC2 instance? So AWS launch instance actually we are using creating auto scaling group. So for the auto scaling, we need to create a launch template. So using this launch template, actually the instance will create after the requirement will increase. So same thing, the name, key name, instance type, security ID, image ID. This is the version. What launch type version we'll use, and auto scaling group. So this is the auto scaling group. So desired capacity is 1. We can do it 2 also. Min size is also 2. I can increase that. VPC zone identifier private. This is the subnet, and this is the target group. So target group actually this will use the application load balancer. So that's why it is using the target group. And this is the launch template, this ID, and this is version latest. So it will use the latest launch type. So that's it. That is in Honda. So this is completed. So okay, so Bastion security group I have explained you. Also need the ALB security group and ALB target group. So ALB security group actually used for the security group for the private instances, and for the ALB target group actually this is using for the auto scaling, which I have provided the ALB target group, because the auto scaling will connect with the application load balancer. So that's why. So this is the ALB application load balancer module. So it is the public subnet I am passing and the VPC ID. So let's see. So this is the variable two thing. This is the LV security. Okay, this is the out. So AWS. So this is the same security group I have created. So it will be public access. So that's why it is CIDR block is anything. Anyone can access this thing. So then the application load balancer is created, and this will be not internal application. Security group is the top one. The subnet will be public, because the application load balancer will be publicly accessible. So that's why the subnet will be public, and depends on the security group. So the target group, we need to create the target group. This is the target group, and it will be port 80 because I am using HTTP traffic. Protocol is HTTP, okay, VPC ID, health check. So actually health check is used for like we can know that if the instance is healthy or not. If uh, so uh, uh, if the instance is not healthy, remove the instance and recreate it. So now that's why we can know that. And AWS load balancer listener. So actually this is the load balancer ID we have to provide, and this will actually the logic. We can change this logic, so we can write the logic in here. So we can route traffic, we can distribute traffic geographically or anything in the routing param based routing. So anything we can do here. So we have to provide the target group. This is load balancer, and this is also the load balancer and dependency. So this is the all thing, and we have to see this thing on the AWS console also. So now I can use the Terraform command. So I have to check if it is already applied or not. Terraform plan. Okay, it is actually asking for reconfigure. No problem. Terraform init reconfigure. Okay. Okay. Now the reconfigure is done. Now we can access the um, I think the S3 bucket and see the state file PPC S3 variant. Okay, no, this is not done yet. So I am writing Terraform plan. Let's see. So it is showing 31 to add. Okay, so everything will be add. So I am applying this thing. Apply. What do I apply? So now it will be applied. Okay, now it is applied. Now I can show you the thing. Okay, now I am going to the VPC. So first it will create the VPC. Sorry. So this is the VPC. Okay, so already it created the VPC. So this is the VPC. Okay, we can see the VPC. In this VPC, we can see that it is also created four subnets. Two public and two private. Okay, and there is route table. So it is also created the route table. Okay, it is only created the public route table, but after some while it will also create the private route table. So the internet gateway. Okay, it is created the internet gateway. So we can see the internet gateway in the route table. So if I click on this, in the route table, we can see that so for the internal traffic, because this is the VPC CIDR. So for this CIDR, it will only go to local, but for the outside traffic, it will go to the internet gateway. So it is created. No, not yet. Internet gateway is here. Okay. So this is the elastic IP for the NAT gateway. So NAT gateway, okay, it is also creating. This is the NAT gateway, and you can see that here is the elastic IP somewhere. Elastic IP should be attached. You can see later. It is just yes, this is the allocation ID. It will attach. The private, okay, the private route table is also created, and if we see, this is the route. So for the internal, it will go to local, and for the outside, it will go to the NAT table. So this is a NAT gateway. So this is the NAT gateway. So now we have to go to the NAT gateway. Okay, this is now available NAT gateway, and this is the public IP. Okay, so if I go to the elastic IP, this will be same. Yes. So this is, and this is the same thing because it is using the same elastic IP. So now this is the network SCL. If I click inbound rule, it will allow all this thing. Outbound rule, it will allow all these things for the other table also. Okay. So here this all ends. The VPC part is done. Now I have to go to the EC2. So in the EC2, so here is three instances. Okay. One is Bastion and other thing is not named. But we can see one thing. There is no public IP for this instance. Okay. Also, there is no public IP for this instance. But for this instance, I can have this public IP. So this is the public instance. We can access this. So I will access this one, but I want to show you the security group. Okay, instance. So actually, this we can also check here. So this is the security group for the Bastion host, Bastion security group. Okay, all access we can get here. But for the private instance, the security group will be. So this is the source. What is the source? This is another security group. For 80, this is the load balancer. For 22, this is the Bastion host. Okay, the same thing for the this one. Now I can go to the auto scaling group. No, EC2 template. Template, launch template. So, launch template, which one is this? I think this will be. So, this is the launch template, and this is the security group for the launch template, and this is the key name for the launch template. Version template tag. Okay, there is nothing. Now, the auto scaling group. This is the auto scaling group. Now, okay, one thing I want to show. So there is instance 2, desired 2, min 2, max 2, okay, and 2 available resource. So it will be also redundant. So this is the all things security group, subnet, 2 subnet, uh, and automatic scaling, security control. So this is the auto scaling, and for the load balancer, no, before the load balancer, I have to check the target group. So this is the target group. And inside the target group I can see that what it is telling. Okay, here is one healthy. I think this is wrong with this one. I think this is not ready yet, that's why I have to check it later. So this is the instance, and it is saying one healthy, and okay, this is for monitoring and attribute target. Okay, there is one healthy only. And for the load balancer, so this is the load balancer. So for the load balancer, I also get the DNS IP, so DNS name. We can check the DNS name. So this is the DNS name. So it will be HTTPS. We have to create it HTTP. HTTP. Okay, so this is working. You can get this one. So this is using HTTP, and this is the listener rule. So this is 100% in one rule. This is network marketing security. So security, you can see this is the security group. Integration, monitoring, capacity. Okay, everything is here. Target group. Now we can access the security group from here. So we can access the instance from here. So this is the instance, and if we type connect, if you say it's client, and type this command terminal. So this is the command. This thing I no need to use. SSH. Yes. Okay. So this is the Ubuntu machine, and how I can check this the Ubuntu machine, and also from this Ubuntu machine I can access the. So for this I need to do one thing. I have to copy this one. Give me 1 minute. Okay, so I need to run this command. So it will copy the local private key to the Bastion instance, because I need to access the other instances using the this key pair. So you need to send the key pair to the instance. So this is send, and we can go to the .sh. Okay, now we can access this one. So now I can access this instance. What is the IP? So this is the IP, the same user. Yes, it is accessing. Okay, one thing I need to say. It's not code solution. So now I think okay. So I can access this instance, but using this IP I cannot do SSH. If I try, I can. So if I try SSH, root, not root, even so this is not possible. Using the Bastion host, this is only possible. Also do one thing, you can check the systemctl status Nginx because there is a Nginx server here. So it is okay. The Nginx server is also running. Okay. And one thing I can do. Mm, one thing. What is this? Okay. I can access the other instance also. What is the other instance ID? This one. Yes. Okay. If I check here, that's it. That is the main problem. Actually, previously I have seen that in the auto scaling group, no, not the auto scaling, target group. Actually, there is showing one healthy and one unhealthy. So that's why because I am using creating the user data. So the main problem is the user data is so I am running this script. Okay. So I am running the script one time, but the uh, auto scaling group will create and recreate the instance, but not the every time this script will run. So this will run only one time. So the for the first instance, the script is running, and it is successfully installed the Nginx server. But for the other instance, it is not working. So for that, you need to manually do this thing. Other thing we can do, we can create a custom AMI. So I can run the script and create a custom AMI, and we can use the custom AMI inside the launch template. Uh, the AMI section. What is the AMI section? It's just image ID. So this is the AMI. So we can use the custom AMI. Yeah. So it will also work. So now I am manually installing this thing. So okay, we can also see one thing. Okay, this is denied. This is timeout. S3 DynamoDB, not S3. S3 this one open. Okay, now we can see the state file. So this is full the state file. Okay, so now we can see one thing. It will be healthy after some time. I can show you. It is now installing. Wait a minute. So there is another problem. So it will run every time, but the every time the startup time will be much more. But if we create the AMI, then it is already pre-building the image. So the startup time will also be less. So systemctl status Nginx. Now it is running the Nginx, and if I refresh it after some time, I think 30 seconds, there will be a how much time I have given private load balancer. Okay, time is not given. Give some, I think after the 30, yeah, 40 seconds, this will work. Purposefully, I have created on a successful and one failed server because we can see if we refresh, only we can getting the successful request because the target group is blocking the request to go to the unhealthy server. So it is only sending the request to healthy server. And if I get two successful server, then we can distribute the traffic also. So let me check. And also this is the same project, same thing I have shown here. One unholy. It will work after some time. It will work. Okay, so we can see that there is now two healthy server. Okay, this is the same instance, the same one. So this is now healthy, and also this is working fine. Okay, this is the VPC, and I can show you one thing for the DynamoDB that it is also working. DynamoDB task instance explore table item. Okay, okay. DynamoDB table also it is showing the Terraform log ID. So I can show you that if I apply Terraform, same command. So here will be created a new row. Okay, here are new. Okay, this one. This one is created because it is running the DynamoDB as a state locking. So after some time, if it is finished, then after some time it will be deleted. Okay. So this is the purpose of DynamoDB for the state locking. Now I think everything is okay. Now I'm destroying this project. Terraform destroy. Also, one thing I can show Terraform output. So I can see the in the output. This is the ALB DNS, which is actually accessing the Nginx server, and this is the Bastion host. So I am purposefully outputting this thing, so we can access the URL from here, and also we can access the Bastion host. So we need no need to go to the AWS console also. So Terraform destroy, destroy, to approve. So this is done. Okay, so this will take time, but I want to show the all of this thing. Okay, so thank you for watching.